Hello ladies and gentlemen, in this video I'm going to do something really interesting and wasteful. I'm going to implement custom animations in Android. Let me explain to you where this video comes from. It's not a secret that I'm kind of skeptical of Jetpack Compose. I don't think that anyone should use it in production in the year 2023 because it's immature and I don't think that it brings anything to the table. I don't think you can do with Compose anything that you can't do with the classical view system, which is mature, battle tested, and gives you all the tools that you need. So that's my position and I voice it on Twitter. In many cases, I get a lot of pushback, like for example, this guy said, can't count how many times we say something like this, that is good enough, we'll create the animation later when we get the time for it, but then never does because it's not worth the work in views. In our Compose app, we have both simple and more advanced animations from start. So the premise here is that you don't implement animations in the classical view system because it's kind of tricky, but with Compose, it makes it so easy that their new Compose app has many animations, and that's a big win. To which I responded the following. I retweeted that and I said, okay, I'll buy it. Give me your killer animation implemented, that's implemented of course, with Compose, and I'll re-implement it using the classical UI and we'll see the difference. Anyone can hand wave, let's make it quantitative. And that's what I actually believe. If you want to compare approaches, you need to go quantitative and compare metrics. So I expected to get a lot of pushback, I expected to get a lot of use cases, but actually I didn't get that much. So I've got just several examples of what people implemented with Compose. And as I said, I will implement these examples using the classical view system in this video, and then we will discuss and compare. Now, before I jump into implementing animations, I want to state the following. Animations in your Android apps can annoy your users. So there is a risk in using animations. Animations are not free. And actually, if you think about it, you cannot greatly improve the user experience inside your application using animations. Whatever great, cool animations, best animations you implement, most probably your users won't care that much. Unless, your app is some niche domain like visual UI stuff, then maybe your users are UI oriented and then maybe they will care. But in most cases, users just want the applications to work, provide value, and do that as quickly as possible. And therefore, any animation that you add has the potential to annoy them. So you cannot greatly improve user experience with animations, but you can actually degrade your user experience using animations. If the animations that you add annoy your users, if they waste their time, then your users will notice the problem and then your metrics will go down. And therefore, be very, very careful with animations. All this posturing on social media with cool animations that developer implemented and showcase to get likes, all of that is great and it's a nice exercise, but that's not something you should implement in your production apps. And that's why if you think about the top Android applications out there, most of them make very limited use of custom animations. Yes, you can use for example, screen transitions. You can use something like bottom sheets with animate, up and down. But generally speaking, you don't see all these, color changes and form changes and, sliding animations from all the corners of the screen. That's not something your users will appreciate. And that's why the top applications out there implement usually very simple UIs, and maybe here and there they add some nuance, very subtle animation to improve the user experience, but they're not stacked stuff with animations. And of course, the reason they're not stacked with animation is not because they don't have the manpower to do that. Google, Spotify, Amazon, Facebook, Twitter, all of these companies, they employ tens, hundreds, maybe thousands of Android developers. Then yeah, surely if animations will be important, they would have the manpower to implement them. So the premise that, somehow view system, the classical Android view system limits your abilities with animations, and that's why applications don't have animations, is flawed. And that's just, people say all kinds of stuff on social media, don't take them seriously. So I wanted just to make sure that we understand that. Don't take this video as an encouragement from me to implement many animations inside your app. This will absolutely ruin your applications. Okay, now switch gears and go to the implementation. Before we begin, I want to just state the following. I don't remember how to implement animations. Really, if you ask me right now to do any simple animation using the classical view system inside my app and I can't use, let's say, Google, then I will not be able to do that. So I start from kind of scratch. I forgot everything. And therefore, I do expect that to take a couple of hours at the very least for me to implement all this tricky stuff. So the first animation that we're going to implement is actually relatively straightforward, and I'm even surprised that someone gave it to me as an example, because this will be relatively simple for me to implement. So we have these 3 buttons, and I think I will just do one button because it doesn't really matter how many of them are there on the screen. So we have a button that has 2 states. The states are basically different colors. In both cases, we have gradients, we have this border, we have a gradient color on the text. And whenever the button changes the state, maybe you can't see that in this GIF, but there's some kind of animation expanding color from, let's say, the center of the button. It doesn't really matter from where the color is expanding. And so that's my first animation that I need to implement using the classical view system. I will get to work now and pause this recording. We'll get back after I have something working. And by the way, I'm tracking my time. I always track my time. So I will be able to tell you how long it took exactly to implement this animation. So we will have some quantitative metrics at the end of this process to compare and understand how much time we can really spare with Compose if we use it for animations instead of this classical view system. Okay, I'll just go and implement that right now. And now I'm back. It's been approximately 1 hour and 15 minutes since I started working on this animation, and now I have the following: a button with a border and gradients. And if I click on this button, it changes the color of the text, of the background, and of the border. Now, of course, I could implement 3 buttons and change, the selected one, but basically all the infrastructure is here, and the additional work is just a waste because I'm not really interested in implementing this feature. So let's just understand how this button was implemented. First of all, I didn't write most of this code. I used ChatGPT, which wrote code for me, and it did quite a poor job initially, but I managed to convince him to improve his code. So first of all, even before I started, I knew that I will go for a completely custom view. Basically, it's overwritten somewhere here. This onDraw method is overridden inside this view. And I knew that from my past experience that, whenever you need something custom, which does not fit exactly into one of the existing views and you want custom stuff, then you basically better off implementing that yourself from scratch rather than trying to hack it around with XMLs and stuff. So that's what I did here. Custom view gradient colored button, that's the name. And here we define several paints and we define gradients. These are our colors, gradient 1 start and end, gradient 2 start and end. My toggle animator class, we will see it in a second. Some parameters, this method set text, which allows to change the text from externally. Toggle method, this is the method that causes the button to change its color. And that's basically all the public API of this element, set text and toggle. And of course, once again, it will be trivial to make 3 buttons and just, on click on one of these buttons to change the 2 others to be different colors, unselected, let's say, and one of them to remain selected, the clicked one to remain selected. That will be trivial, so I'm not even trying to do that. I hope you understand that. Okay, we'll override this onSizeChange method to calculate some stuff and update the gradient. So this update gradients method is what updates the gradients and then calls invalidate. Now, the initial implementation by ChatGPT put these lines of code into onDraw method, and of course that's not something we want to do because we don't want to perform these calculations every time onDraw is called, and therefore I basically asked it to put these lines of code in onSizeChange. And when I think about it now, I could probably also move these 2 lines into onSizeChange as well to make sure that we don't perform any unneeded calculations in onDraw. That's just performance optimization. Okay, maybe I will move these lines after we complete this recording. And then basically in onDraw, I just draw the background, draw the border, and draw the centered text inside this border. Basically, the interesting part here is, of course, this toggle method. And I use this myToggleAnimator class, which wraps around some animator, value animator, and RGB evaluator. Initially, ChatGPT wanted to use 4 different value animators, and in each one of them, when this update listener is called, it wanted to call this update gradients method, which calls to invalidate eventually. So that will be very inefficient. That will be too many invalidations of this view. So not efficient in terms of the performance. So I refactored this part manually. I just extracted this my toggle animator class, and this class basically encapsulates this animation that toggles the color of this button. And as you see, all in all, very simple, relatively straightforward implementation. Of course, if I wouldn't have ChatGPT, it would take me more time to write that because I didn't remember any of these APIs. But since we have ChatGPT and we have Google, there was absolutely no reason for me to, try to implement that myself. All in all, we have here about, 120 lines of code, and some of that, of course, are imports, some of that are just white spaces. But let's say around 120 lines of logic inside this gradient colored button custom view. And let's compare that to Compose implementation now. So that's the implementation that one of my Twitter followers who gave me this task, this homework, provided. And that's the implementation of basically the same element, or at least very similar element, using Jetpack Compose. And we see that it's indeed much more concise, much more packed with stuff. But even though it is more concise, the question of whether it will take much less time to implement this element rather than what I implemented is not quite straightforward in my opinion, because, for example, I forgot about all the animation APIs and I forgot how to work with custom views in Android. So I had to use ChatGPT, and then I had to kind of massage this code to make it more beautiful, more performant. I don't know if I would need to use these animations, these APIs from scratch, Compose APIs from scratch. I don't know. I'm not sure. It will take me less time actually. And I'm pretty sure that my implementation is more readable and surely more extensible. So for example, in this Compose code, the animation is handled by this animate as state method. So it handles all the animation. It hides quite a bit of magic under the hood. And of course, I could kind of extract, let's say, this class or some of these methods from this class and reuse it. But I prefer to do it like this. This class is very simple to read now, and it's very simple to modify. So for example, if I would want to change the animation in any way, it will be very straightforward. I have this my toggle animator, and whatever I want to animate, I can just put here. I can animate additional properties because this value animator is not bound to color specifically. So if I would need to extend this gradient colored button in any way, I claim that my implementation is more extensible and that my implementation is even more readable because everything is just right here in front of you. There's like no magic here as long as you understand what, let's say, onDraw method does and what invalidate does. But there's like a little bit of performance optimizations that I implemented, and let's say maybe a less experienced developer could actually miss these performance optimizations and create some non-optimal implementation. So that will be the risk. But overall, I'm not convinced that implementing this element with Compose would be much faster. So I spent 1 hour 15 minutes to implement this element, even though I forgot everything. I don't know. I can be sure that it will take much less time if I would use Compose, or someone who knows Compose but wouldn't know how to implement animations would implement it with Compose. I'm not sure it will take much less time. And also I claim that this implementation is more extensible. And the fact that I have 120 lines of code as opposed to Compose 30 lines of code is actually, who cares? All of that is encapsulated inside this one single class, gradient color button. And that's why we do object-oriented design, right? We want to encapsulate code related to specific features inside specific classes. And once we did that, we don't really care how many lines of code are there. So all in all, as I expected, this task of implementing, once again, let me show you, this button that changes its colors is not very complex to do with views, and therefore the claim that Jetpack Compose makes these tasks somehow more accessible and easier to do, well, I don't buy it. Yes, definitely we can implement this element with less lines of code using Jetpack Compose, but again, who counts the lines of code? Who cares how many lines of code did ChatGPT or even you yourself write? What's important is that we write a clean code, we write performant code, and we write extensible code that encapsulates basically features inside classes. And that's exactly what I did here. So just from this experience, I don't give Jetpack Compose any like winning points for this one, but I will transition to the next one, which is more interesting, more involved, and maybe there Jetpack Compose will shine. So let's get to it. So the next animation, which supposedly Jetpack Compose makes so simple to implement and would be so difficult with the classical view system, is this. So we have two buttons, minus and plus, and when we click on plus, we have these numbers going up or down, and there's some animation. And of course, someone added there even this matrix reference as though it's some kind of exceptionally impressive, very difficult thing to do. Okay, now let me tell you that even if this animation will take 1 or 2 days to implement, I doubt that. We will test this assumption right now. But even if it would be a very complex animation, like really, it's not matrix stuff. There are features sometimes that you work in Android apps, complex features that can take weeks, sometimes months to implement properly. So, like putting this matrix reference for an animation is kind of an overkill. So we have this animation. When I click on minus, these numbers go down, and then we have this also animation. Notice the fade out, fade in animation, and also there will be slow motion now, and you can see that all of them go up and down. And if you click on minus or plus when these numbers go up or down, then those who are still visible just reverse their course, reverse their fade out animation to be fade in, and reverse their, let's say, up motion to down motion. So the person who posted this GIF insisted that it's something really, really complex to implement that will take a lot of time. So we will test this assumption right now. And again, I will pause this video, implement this feature, and then we can discuss how long it took me to implement this feature. And we will go over the source code to understand how I implemented it. Okay, I implemented the required animation. So now we have this screen, and that's the previous animation with this very fancy button. And here at the bottom, you can see this plus and minus stuff. And as you can see, these numbers go up and down. And I can reverse them, right? If I do minus and then I do plus, then the number that is still on the screen reverses its direction. So I can do like this, okay? Juggle them around. So that's the required outcome, and in total it took me 4.5 hours to implement this animation. Now, during this time I was also babysitting my baby, which stayed at home sick. So I worked in short bursts of time, and I'm pretty sure that if I would do that, like, if I could have concentrated and just did that in one single go, then I would probably do that twice as fast. But still, 4.5 hours for a very complex animation is absolutely fine with me. Now, let's understand why this animation is complex. And this one I wrote completely by myself without ChatGPT, because actually it's simpler in terms of drawing and stuff, but it's much more complicated in terms of the state. And therefore, I kind of anticipated that ChatGPT will not be that useful in this context. So what's the complication? Well, let's get just, right to it. This is the complex part. This took me like most of the time to implement this method and debug it afterwards. And what happens here, well, first understand what's that. This is a finite state machine. And basically each of these elements on the screen has a finite state machine associated with it and has an animation. And there are multiple elements, there can be multiple elements on the screen, and therefore we have multiple finite state machines and multiple animations running concurrently. But it's even more difficult than that, because the user can interact with this element and change the state of those elements. So not only those elements kind of animate in some very complex manner, but also the user can change the state, and then the elements should react, all of them should react to the change in state. And by the way, you can see that, I have some animation here, and I didn't invest that much time to, implement some custom interpolator and stuff. This is not worth my time. I implemented just the most important part of this animation, and of course it will take another couple of minutes to modify that. Okay, so this is the finite state machine, and we have the state, animation state, and the animation can be in multiple states. Either none, that's the state when the animation, well, the element is just added and the animation hasn't started yet. and then entering from top or bottom, settled, which means that the animation completed and now that element is in the center of the screen, exiting to top and exiting to bottom. And what this code does inside update animation method is it calculates the next state given the current state and some basically constraints, and in addition sets the parameters for the animation that will be carried out. And here, after I calculate the next state, if the new state is equals to the current state, then I don't do anything, but if the state changed, then I cancel the animation and start a new one. And by the way, here you can see this invalidate call, and I was wrong in the previous animation. I thought that, having multiple invalidate calls will be performance drawback, but actually the framework is clever enough to batch these invalidate calls. Basically, this invalidates just sets a flag, and then when the time comes, the framework calculates and calls to this onDraw method right here, onDraw. And there's like a bunch of other logic around this animation. And for example, when I increment or decrement, I just check whether this visible labels list contains the label with the next count, because if it does contain the label, then I need to animate that element and basically change its state. But if the respective label isn't in this list, so there are no visible element with the required count, then I just need to add a new one, and respectively, very similarly, decrement method. Okay, so this is really a complex animation. And again, what makes it complex is this state machine that is associated with each of these elements that are animating on the screen, and the fact that the user can affect the state of each of these elements. So that's the complexity of this animation. And that's why I had to spend more than 4 hours implementing and mostly testing all of that and, catching the edge cases and understanding what I did wrong. But eventually we have this animation and it looks quite great. Now, before we jump to see its Compose counterpart, let's just see how many lines of code I used. So that's in total about 250 lines of code. And of course, I could shorten many lines of code here by writing code a little bit differently. And I surely could optimize this update animation method because some of these are repeated, and I could extract another data structure to hold all this anim start and anim target, but I won't do that because really I spent way too much time on this video already. And again, I have all of that encapsulated inside this animated counter, and this code is very simple to read. It's not a simple code, it's a tricky code, but it's very simple to read and understand once you dive into it. And therefore, I'm pretty sure that the fact that I have this long method will not be a maintainability issue going forward, because it always can be refactored, and since it's encapsulated, the impact of this non-optimal code is limited to just this one single class. So that's totally fine with me. Okay, 250 lines of code. Let's see what's going on in the Compose world. Okay, so this is Compose code that implements this same animation that you've just seen on your screens. And I counted there are about 30 lines of code here. So this code is shorter by a factor of approximately 6. Now, in my opinion, this code is way too dense and it is unreadable and therefore hardly understandable. So I will just, space things a little bit and break some lines here. And maybe in total, it will take, let's say, 50 lines of code to implement this animation using Jetpack Compose. So we still have a factor of 4, which is kind of big factor. So it would take you 4 times more lines of code, not 4 times more code, but 4 times more lines of code to implement the same animation in views as opposed to Jetpack Compose. And please notice that here, why it's shorter? Because here in Jetpack Compose, you can use this slide in vertically and slide out vertically functions. And what this means is that there's some full-time employee probably at Google who sit down and just captured the same code, the same animations that I implemented myself. They captured it, put it as part of the framework, wrapped it in this slide in vertically, slide out vertically functions. And now developers who use Jetpack Compose can use that. So it's not exactly that Jetpack Compose makes it simpler to implement, but they just added the respective APIs that make it simple. So this makes this code much shorter, but on the other hand, I think that this code is much less flexible than my code, because in my code I can change basically anything, and here we are limited to these functions. And if you would not use these functions, then this short and concise piece of code would blow up considerably. Okay, so a factor of 4 approximately between Jetpack Compose and View system. Now let's ask some very interesting questions after we've seen these two animations. One of them is arguably quite simple and another one is arguably quite complex. Is animation code using Jetpack Compose shorter? Yeah, definitely it is. Is animation code using Jetpack Compose simpler? Now, this is a question of personal preference and what you know, etc. But the answer is not sure. I'm not sure that it's simpler. I'm not sure that all these functions that you need to memorize and understand what they do, or if you don't know what they do, you need to infer what they do from their names, are simpler to understand than just plain code that you can go and read line by line if you need to modify that in some cases. So I'm not sure that Jetpack Compose code is simpler. Is it faster to implement animations using Jetpack Compose? Again, I'm not sure about that. Yeah, sure. When you see the end result, you think, okay, these are 40 lines of code and these are 200 lines of code. So this probably is much faster to implement. No, it doesn't work that way. Jetpack Compose animations are faster to implement because you have these higher level functions that you can use. But on the other hand, if you need any customization that is not supported by those functions, well, I would like to see someone implement this animation from scratch in Jetpack Compose, and then we could maybe compare the results. So I'm not sure that it's faster to implement it using Jetpack Compose, but I'll give it the benefit of the doubt, and let's say it's twice faster, which is quite a big and quite a favorable assumption for Jetpack Compose. Okay, now, is there anything you can do with Jetpack Compose that you can do with Views? And the answer is no, of course. You can do everything with Views, and really, I'm not a UI guy. My kind of niche in Android is architecture, best practices, concurrency, unit testing. I don't write user interfaces. I don't take projects that involve complex user interfaces. Clients don't pay me to write user interfaces. I will be much too expensive and much too unproductive compared to other developers for that purpose. And the work that I've just did on animations, well, in the past 6 months, or maybe in the past year, I performed less animation work than that for all my clients and all my courses. So I'm not a UI guy, and that's not my strongest suit. And still, it took a couple of hours and I found the solution. So everything you can do with Jetpack Compose, you can do with Views. And then, is the difference between Jetpack Compose and Views in the context of animations important? And let's say, again, favorable assumption, let's say that Jetpack Compose cuts the time you spend on implementing animations by 2. And let's even say that the resulting code is more readable, more maintainable than the code that I wrote for Views. Okay, all these assumptions, let's just make them. Is the difference important? And the answer is absolutely no. And I started with that, and I want to conclude with that. Animations in Android, and actually in any programming framework, animations are kind of niche topic. You need very few animations in your applications. Usually you don't need complex animations like I implemented right now. Something like that will probably come out of the framework itself. Usually you don't do that. I've never needed to implement this kind of animation in either of my projects. And in most applications that I ever worked on, they would have maybe 1, 2, 3, 5 animations in total for the entire project. So the difference between Jetpack Compose and Views in the context of animation is absolutely negligible. And really, I spent so much time on these animations, more time than I spent in the past year working for the clients on animations. So that's your answer. It's not important. It's really not important. And of course, that's just my personal opinion. Other developers might have other opinions, like for example this guy who said that he implemented something in 40 minutes which other developer implemented in 7 days. And then he says, okay, it's such a noticeable difference, there is no need to measure honestly. Well, first of all, there is a need to measure always, and second, there's simply no way this thing is true. Well, assuming that they are comparable level developers. If this guy has 10 years of experience and his pal had 2 months of experience, then yeah, maybe he spent 7 days on animation, even though I find it very, very difficult to imagine an animation in Android that will take 7 days to implement. But okay, let's say. But otherwise, this is just not in the realm of real possibilities. But you still see all these people online claiming that Jetpack Compose is so great and gives you all these benefits. I am not convinced, and hopefully now you've seen the benchmark, you know the metrics, you've seen me doing that. I'm not the best UI developer out there. I'm pretty sure that other developers who deal with complex user interfaces on a regular basis would be much faster than me in implementing these two animations. So just be aware that, many developers, they kind of try to justify maybe their choice. They jumped into Jetpack Compose, spent all this time learning it instead of, learning a little bit about view system and then being productive with views. And now they try to justify it. So they claim all kinds of really completely impossible benefits to Jetpack Compose. I think it's good to be aware of that. And I think that you always should ask for a benchmark for metrics before you believe anything people say online. Hopefully this video helped you in kind of making up your mind. Maybe you decided to go with Jetpack Compose, and that's fine too. Maybe you decided that you just need to learn a little bit more about views. That's fine too. Okay, that's it about Jetpack Compose animations as opposed to view animations. The last thing I would like to mention is that if you liked this kind of content, going deep and seeing complex stuff, then I created several courses aimed at professional Android developers. And if you'd like to check them out, I will leave a link here below this video. Okay, thank you for watching and see you next time.